Today we're going to evaluate definite integrals, and so what that is going to give us is the area under the curve between two specific x values. So if we look at our first example, we have x squared plus 1 from -1 to 2. Okay, so what we're going to do first, how we know this is a definite integral, is there's two little numbers on our integral symbol. So first thing I'm going to do is take the derivative right here. Remember, anytime it's an integral, this is the derivative. So we're going to go backwards and do the antiderivative. Okay? So I'm going to take this coefficient 1, okay, and I'm going to divide it by the new exponent, and we're always going to add 1 to it. So that's going to be 1/3 x cubed plus, remember, if it's just a number when you're doing the antiderivative, you just tack an x on with it. Now, when you're doing definite integrals, okay, that's when there's a number here. You don't have to put a plus c. So you don't have to do a plus c with definite integrals. So I don't need to put the plus c here, because what's going to happen if you put the plus c, they're just going to end up canceling out. So to save us some time, we don't need to write it. Okay? And so then what I'm going to do with these numbers, instead of having the integral symbol, because I've already done the antiderivative, I'm just going to draw a line at the end and put the two numbers there. Okay. Now what we're going to do is plug these two numbers in and subtract them. So I'm going to plug in always the top number first. Okay, so I'm going to do 1/3 times 2 cubed plus 2. I'm going to figure out what this is, and then I'm going to subtract whatever I get when I plug in the bottom number. So that's going to be 1/3 times -1 to the third plus a -1, so -1. Okay. So 2 cubed is going to be 8, so that's going to be 1/3 times 8 plus 2. Okay. So that's like 8/1, so multiply your numerators, multiply your denominators. That's going to be 8/3 plus 2. Okay, so 2 is 2/1, so I'm just going to multiply both of these by 3/3. So that'll be 6/3. So 8/3 plus 6/3 is going to be 14/3. Okay, so that's what I get for this part. Then I'm going to subtract whatever I get over here. So -1 to the third power. A negative number to an odd power stays negative. So that's going to be 1/3 times -1 minus 1. Then 1/3 times -1 is just going to be -1/3 minus 1. That's like 1/1, so multiply by 3/3 to get a common denominator. So this is going to be a -4/3. So I'm going to do 14/3 minus a -4/3, which is going to be 14/3 plus 4/3. That is going to give me 18/3, which will divide to give me 6. Okay. So this definite integral, when we evaluate it, it gives us 6. So now let's go ahead and look at a trig definite integral. So we've got antiderivative from 0 to pi of sine of x. Okay, so anytime you're doing the antiderivative of a trig function, remember we're looking on the right side of our integral sheet. Okay, so if I go look for sine of x, I can see that becomes negative cosine of x plus c. Okay, and then we don't need the plus c here. So I'm going to rewrite this. When I do the antiderivative, it'll become negative cosine. I'm going to plug in pi, and I'm going to plug in 0 and subtract those two numbers. So what we're going to do is negative cosine of pi. You always plug in the top number first, and then we're going to plug in the number on the bottom and subtract those. Okay, so pi, that is going to be on the left side, so -1, 0 will represent that point. Remember, x is always cosine, y is always sine. Okay, so cosine of pi is going to be -1. So this is going to be a -1. Okay, then 0, that's going to be on the right side. So that's 1, 0. So the x value is always going to be cosine. So that's going to be minus a negative cosine of 0 is 1. Okay. So a negative negative 1 is positive 1. Minus a negative 1 is going to switch to plus 1. So 1 plus 1, 2. So let's do another trig example where it's more than just a single trig function. Okay. So again, we're going from 0 to pi. Of cosine of x, now we have this plus 1. Okay. So look on your integral sheet. Okay. If you find the antiderivative for cosine, I can see that that goes to sine. And then I don't need the plus c for the definite integral. So anytime there's a number here, numbers on the top and bottom of your integral symbol, you don't need the plus c. So antiderivative of cosine is going to be sine of x. Then the antiderivative of 1, that's just going to be plus x. Then I'm going to plug in pi, I'm going to plug in 0, and subtract what I get for those two numbers. So when I plug in pi, okay, again, pi is going to be over here on the left. So that'll be negative 1, 0. Okay, x is always cosine, y is always sine. So I'm going to do sine of pi plus pi. So I'm going to figure out what this is. Then I'm going to subtract whatever I get when I plug in 0. So sine of 0 plus 0. Okay, so for the sine of pi part, I need to come over here. I need to look at the y value. That's 0. So over here I have 0 plus pi, which is just pi. Okay, so here where it's just an x and I plugged in pi, you don't actually need to do anything here. The value is just pi. You only need to look at the ordered pair and get either the cosine or sine value when it says sine or cosine of pi. And then I'm going to subtract whatever I get here. So if I look at 0, which is on the right side, that's 1, 0. My sine value is still 0. So sine of 0 is 0, plus 0, 0. So 0 plus 0 is just going to give me 0. So pi minus 0, that is just going to be pi. Now let's look at one more example with a fraction and radicals in it. Okay, so we have the antiderivative from 1 to 4 of x squared plus the square root of x all over x. Okay, so remember when the expression is one big fraction, you're going to have to split it up. Okay, so I want to rewrite this as x squared over x. Okay, plus remember square root is to the 1/2 power. And then to simplify, when you're dividing, remember we are going to subtract these exponents and we want to bring everything up because just like we don't want to do the derivative when there's an x on the bottom, we don't want to do the antiderivative with an x on the bottom. So here we have 2 minus 1, so that's just going to be x to the first. Here I have 1/2 minus 1, so that's going to be x to the negative 1/2. Now I can go ahead and do the antiderivative. So this part right here, when I add 1 to the exponent, that's going to give me a new exponent of 2. So my coefficient is going to be 1/2 x squared. Here, when I add 1 to the coefficient, okay, so negative 1/2 plus 1 is going to be positive 1/2. So this is going to be 1 divided by 1/2. And so then I'm going to go ahead and simplify this fraction in a fraction. So that would be 1, you leave the top the same, and then you multiply by, you flip the denominator. So 1 times 2 over 1 is just going to be 2. So this is going to simplify to 1/2 x squared plus 2x to the 1/2. Then I'm going to plug in 4, plug in 1, subtract what I get for those two. So this will be 1/2 times 4 squared plus 2 times 4 to the 1/2. So I'm going to figure this out and then subtract whatever I get when I plug in 1. So that's going to be 1/2 times 1 squared plus 2 times 1 to the 1/2. So 4 squared is 16. So this will be 1/2 times 16 plus 2 times, remember, 1/2. This means square root. Okay, so this 4 to the 1/2, that's the same thing as the square root of 4. So square root of 4 is 2. So 1/2 times 16 is 8, plus 2 times 2 is 4. So that's going to give me 12 for this first part. Here, 1 squared is 1, so that's just 1/2 times 1. Plus 2, this 1 to the 1/2 is same thing as square root of 1. Square root of 1 is also just 1. So this is going to give me 1/2 plus 2, which is 2 over 1. So that'll be 1/2 plus multiply by 2 over 2. That'll be 4 over 2. So that's going to be 12 minus what I end up with here is 5/2. Then I'm going to get a common denominator here. This is 12 over 1, so multiply by 2 over 2. That'll be 24 over 2 minus 5 over 2 to give me a final answer of 19 over 2. So this was 1 through 4 on today's worksheet. You just need to finish the rest of it for homework, and it will be due by the start of class tomorrow.